So this is ELC 131, Circuit Analysis 1, and the topic is the introduction to electricity. Now, electricity and electronics are based on the motion and control of electrons. With the exception of our discussions on electromagnetism, we are generally concerned with the motion and control of the valence orbit electrons. And the valence orbit is the outermost orbit of an atom. And the reason we're concerned about the valence orbit is that the attraction to the nucleus of a valence orbit electron is very, very weak. Now, we have a pictorial of the model of an atom. And of course, as you know, in the center of the atom is the nucleus made up of neutrons and protons. And orbiting the nucleus are electrons. The protons have a positive charge. The electrons have a negative charge. Now, when an atom comes from the atom factory, it has an equal number of electrons and protons. So there are 3 protons in the nucleus of this atom. I've only drawn or symbolized 1. Now, since the valence orbit electron is loosely bound to the atom, if we apply some energy to this atom, and the energy I'm going to apply to this atom is in the form of thermal energy from a candle, this energy has to be transferred somewhere. And the energy is transferred into the motion or movement of this electron. When the electron leaves its valence orbit, it gains some energy. Now, we'll talk about this later when we get into electronics, but when the electron, or when a electron leaves the orbit of an atom, it leaves behind what we call a hole. Now, this is not a hole in the sense of a hole. It's just merely a place in this orbit where there should be, everybody would be happy if there were an electron here. But the addition of energy to this atom has caused this electron to get knocked loose and become what we term a free electron, simply meaning that that electron is not in the orbit of an atom. Now, these electrons don't like to be out here in space by themselves. They want to be with their other electron buddies. So this electron will fall into the orbit of another atom. And when this happens, notice the atom on the right now has more electrons than it does protons. And this particular atom becomes a negative ion, simply meaning that it has a net negative charge because it has more electrons than protons. This atom on the left that has lost an electron becomes a positive ion, simply telling us that it has more protons than electrons. And it's this motion of electrons that is what electricity is all about. Now, if I could take some body, and not somebody, but some body, and rip a bunch of electrons loose from it, then I would have a charged body. And if I rip electrons loose from this, then it now has a positive charge. And if I can somehow put all those electrons on another body, then this body would be a negatively charged body. This one has a deficiency of electrons, and this body has a surplus of electrons. Now, if we charge these bodies, we find that bodies that have unlike charges are attracted. Bodies that have the same charge are repelled. And why does this happen? Well, existing around these bodies are lines of force. And the lines of force, the direction of these lines of force is different depending upon the charge on these bodies. And these lines of force are called electrostatic lines of force. Now, these lines of force are quite similar to magnetic lines of force. We can't see them, we can't smell them, we can't taste them, but we know they're there because of the way these bodies act when they're in proximity. And what happens with these two oppositely charged bodies is that these lines of force will link together and actually pull these bodies together. If they were two oppositely charged or similarly charged bodies, then these bodies would be forced apart because their lines of force would be pushing against each other. Similar to magnets, if we have a magnet with north to south and another magnet north to south, these magnets would be attracted because their lines of force link together. If we have two similar poles, then these magnets are pushed away because their lines of force are going in opposite directions. So again, electricity and electronics are all about electrons, the motion and the control of electrons. We're generally concerned about the valence orbit electrons because those are the ones that are most easily knocked loose from the atom. If I apply energy to an atom, it loses some electrons. And if I can find a way to deposit those electrons onto another body, then of course I can create these charged bodies which exhibit the presence of electrostatic lines of force around those bodies. And it's those lines of force that affect the attraction or repulsion of these bodies.